Post-secondary proportions. So we are now in Module 2, Topic 1. And this will be Lesson 1. Okay, so how do I solve these? Hopefully you remember that you would do a cross multiplication. So if I multiply these two together, I would get 16x. Then I would multiply these two together, and 7 times 48 would get me 336. I divide both sides by 16 like we've been doing, and I get x equals, try that again, 336 divided by 16. I would get 21. Okay, so we try that again. Okay. I multiply these two together and I get 450. I multiply these two together and I get 9t. I divide both sides by 9 and I would get 50 is equal to t. This one. Okay, so 1 is the same thing as 1 over 1. Any whole number is over 1, so I multiply here. 1 times p is just p, and I multiply these two together, and I would get 10. Again, 250 is over 1, so I multiply these together right here, and I get 1,000 equals, and I multiply these two together, 250q. I divide 250q on both sides. If you don't know, that goes like that because I can divide out 10 on both of them. 100 divided by 25 is going to get me 4. Okay, so now look at the next page, getting started. Ratio of women to men. Okay, government agency and a civil rights group monitor enrollment data at universities. To ensure that the different groups are fully represented, one study focused on the enrollment of women at a certain university. The study found that 3 out of every 5 students enrolled were women. Okay, so that means 3 were women out of a total of 5 students. So it's asking the number of enrolled students to the total number of students. So we want female to total of students. So if I do that, I have 3 out of 5. The next one is asking male to total. Well, guys, if I have 3 female and I have a total of 5 students, all I have to do is subtract that and I would get there are 2 male out of a total of 5. Okay, now this next one is asking for female to male. Well, we just said female was 3. We just said male was 2, so 3 to 2. Now this time it wants male to female. 2 to 3. Okay. So, determine the number of female students to the total number. So didn't we talk about that was 3 to 5? So now we're going to set up a proportion. Okay, so if I have 3 female, I'm going to actually write this off to the side. Female to total. If I have 3 female and 5 male, but I want to know the total number of females. So I need to set up this proportion. So this gets me 5x equals, this gets me 45. I divide by 5 and I find out when there are 15 total students, there are 9 females. Okay? Again, 3 to 5. We're looking for how many females? We have 250 total students. I multiply 5x. I get 2 times 3, so that's 750. Oops, sorry, I didn't show that. I divide by 5 on both sides, and I get x. That goes in 1 time, 150 female students. Okay, again, same thing. 3 to 5 for female students. So, I multiply here and get 5x. I multiply here and I get 12,000. I divide by 5. I get x equals 5 goes into 12. 2 times with 2 left over, that'll get me 4. And that would be 2,400 female students when there are a total of 4,000 students. So, well, right here, we're going to do this, and okay, this is total number of students. This is male students. Well, if there's 0 students enrolled, there's got to be 0 male students. Okay, so if there are 250 total students, okay, so this is looking for male students. Well, look up here. We already did 250 students, and there are 150 female. So if I have 250 students, and there are 150 females, that means that there are 100 males. Now that one was easy to do. This one, it's not that it's not easy, but we have to actually set up and do a proportion. Oh, that's what this B area is for down here. Remember, there's 2 to 5 for male students. So that would get me x over 6,000. When I multiply, I'm going to get 5x equals, I'm going to multiply, I'm going to get 12,000. I'm going to zoom in here. I get 5x. So that goes in 2400. And that's male students. So this would be 2,400. Now this time, right here, they're looking for the total students. So it's still 2 to 5, but we're looking for the total students. We have 6,000 male students. So now we're looking for the total amount of students. So if I multiply here, I get 30,000. I multiply here, I get 2x. Divide by 2 on both sides. And I get, I have enough, 15,000 students. So this one would be 15,000. Okay. Now, this one says female to male. So if I have female to male, we said on the other page that was 3 to 2. There are 800 students are male. So we have to find the female. So we do like we've just been doing. I don't know why I decided to go that way first. I'll go this way. Actually, I'll undo it. I'll go this way first. That gets me 2x. It doesn't matter which way you do first at all. And that'll get me 2,400. So I divide by 2. X equals 1200 female students. Okay. Now, we are going to find the comparison for the equations. Okay? So when we talked about 2 to 5 up here, what were we talking about? If I come back to this page, when I was talking about 2 to 5, what was I talking about? I was talking about male to whole. Okay, so this one is male to whole, or total. If I was talking 5 to 2, this would be total to male. 3 to 2. Well, I don't remember that one off the top of my head, so I'm going to come back here. 3 to 2. Oh, that was female to male. Okay. So the number of female students is Y. So that's female to the total number of male students. So, female to male. If I was to multiply this right here, I would get 3x over 2 equals y. Isn't that one the one that we just talked about? Okay, so this one says male to total. So y is male, x is total. Male to total we talked about is 2 to 5. Okay, so if I was to multiply this one right here, I would get y equals 2x over 5. That's the same thing as y equals 2/5 x. This one, I have female to male. And we said that's y to x. So female to male is 3 over 2. So if I multiply this, I get y equals 3x over 2, which is the same thing. Oops. Same thing as y equals 3 over 2 x. This one's male to female. Okay, and that's y to x. Oh, that was ridiculous. Y to x equals male is 2, female is 3. So if I multiply this to the other side, I get y equals 2x over 3. Okay? What are the similarities in each one of them? Well, the ratio is the same as before. Nothing added or subtracted. Okay. All of it is y equals something and then x. Okay. So we said the total number of female students, y equals female students was 3/5 x. So if I was 0, 1, 2, 3, 4, 5, 7, 8, 9, 10, 12, 13, 14, 15. 1, 2. That's weird. Did I go off a little bit? No, I didn't. So if I had 0 students and I was going to plug that in, y equals 3/5 times 0. Y would come out to be 0. And I'm going to pick by 5s because the denominator is 5. So if I was to pick 5 Oh, sorry. This is total students. This is number of students. Okay? So if I picked 5, these would cancel and I would get y equals 3. So 5, 3 would go here. If I was to pick 10 total students, 5 goes into 10 twice, so y equals 6. So if I go 10, I go up to 6, and if I pick 15, goes in 3 times, so y equals 9. So 15 gets me 9. So if I was to draw this, okay, so we're going to do the same thing over here. This time it's y equals 2/5 x. So this is 0, 1, 2, 3, 4. And this is total number of students because that's what the x value is. And this is number of students. Okay. And this is 1, 2, 3, 4, 6, 8, 9, 10, 12, 13, 14. Okay, so if I was to plug, I'm actually going to plug it in over here. 2/5, so I was going to plug in 0, that would get me y equals 0. If I was to plug in 5, I'm doing this so that it cancels out the denominator. So if I picked 5, I would get 2. I'm going to plug in 10. 5 goes into 10 twice. I would get 4. So 10, 4. And then 15. Goes in 3 times, so I get y equals 6. Okay. There we go. Now, what do you notice? Okay. They both go through the origin. If you don't remember what that is, that's the point 0, 0. They both make a line. Actually, in this picture, it's actually a ray, but it would make a line if it went into the second quadrant. And the third quadrant. Now, difference. How steep it is. Remember we talked about steepness before? How steep it is. How high it is. This one is much taller than this one. This one's not as tall. Okay, so what we're going to be talking about, and I'm going to do yellow. A proportional relationship is one in which the ratio of the inputs, or the x values, to the outputs, or the y values, is constant. It stays the same. Made a straight line. It didn't deviate. It stayed exactly the same. Okay? So we had 2 to 3. These are always written in this form. This form right here. Y equals kx. And that k is what is called the constant of proportionality. The constant of proportionality. So from question number 4, this one right here, 3 over 2 is the constant of proportionality. You know what? I'm going to highlight them. This is my constant of proportionality. This is my constant of proportionality. Constant of proportionality, constant of proportionality. So when we write this, we would say k equals 3 over 2. K equals 2 over 5. K stands for the constant of proportionality. Those are the constants of proportionality for these. Oh, we have to do it here too. So if I was going to see this right here, okay, so it's y over x. So how tall was this? How tall was it? It was 3 tall. How far over did it go? It went over 5. So my constant of proportionality is 3 over 5. Well, look at that. Then this one, the y, or how tall it is, over how far it went over. Look at that. It stays the same. It's the constant of proportionality. Okay, comparing the ratios and graphs. So we're going to look at this. Remember, it's y, it's y over x. So we're going to see how tall it is. So let's see how tall this one is. Let's see. How tall is that? Well, it's 10 tall, and it went over 25. So this one is 10 over 25, which if I simplify that, 5 goes into both of them, so 2 over 5. So 2 over 5 is one that we've already looked at. So now let's look at this one. Okay, so if I looked at this, oh, you know what? Let's make it a different color. Make it green. So if I went here, the height on that one is 15. If I went over here, it's still 25. So it's 15 over 25. If I simplify that, that gets 3/5. So the green that I just did, that deals with the females. Because isn't that what our constant of proportionality was before? And for the males, it was 2 to 5. Okay. Oh, we did this one already. We did this. I just wrote it on the lines. Okay, so now the ratio of the number of students who enjoy music, so somebody who likes music, to the total number. So music to total. Okay? It's slightly more than the ratio of females. So if the female is this, if it's more than, we can make it 4/5, couldn't we? So draw a line. So that means we're going up 4. So if I wanted to do 4/5, so that's going to be a little more difficult on this one. So let's say y equals 4/5 x, because that was what we talked about before. What about if we did 10 students? Let's see where we would be if we had 10 students. So that would go in 2 times, so that would be 8. Okay, so 10, 8 is about there. So let's try 20. 4/5 and 20. Oops, 20. That goes in 4. That's going to be 16. So that's a little bit here. So let's try 25, because the other ones worked on 25. So let's try 25. So that goes in. That's 5. That would be 20. Look at that. So that means this one would be 25, 20. So and that would be y3. That would be the third line. And this one would be of music students. Okay. Then this one wants full-time students. So let's pick a different color. We'll pick the purple this time. This one's full-time students to total students. But it says is less than the ratio of male. So it has to be less than. Now, does it have to be perfect, boys and girls? No. I just have to find one that goes below this line. So I could actually not even try and figure it out and just draw this line. And that means that its constant of proportionality would be less than those of the males. Okay, who has the steepest? So which one is the tallest? Okay, so the tallest would be music. Then what's below that? Below music is going to be the females, then the males, and then the full-time students. So let's see what the rest of it's asking. Which is the steepest? We said that the music was the steepest. Okay? And its ratio was 4 to 5. Okay? The ratio is higher than the others. Okay, comparing speeds. I'm going to go back to blue because that's my favorite color. Daisy attends college in another state. During summer break, she drives home from college to visit her family and friends. Daisy decides to keep track of the time that it takes her to drive home from school. She records the distance over here for various numbers of hours. Her data is shown in the table. Does this table represent proportional relationships? So, in order to do proportional relationships, remember it has to be y over x. And it would have to be constant. It has to be the same every time. So I take 180 and I divide it by 3. When I take 180 divided by 3, I'm going to get, oops, that was weird, 60. Then I'm going to take 120 and I'm going to divide it by 2. What do I get? 60. I'm going to take 90 and divide it by 1.5. If you put that into the calculator, you would get 60. 150 divided by 2.5, and you would get 60. Okay, write a ratio for distance to time. So distance, we wrote, I should say, didn't we just write ratios of distance to time? And when I simplify each one of them, I got this ratio. And that was standing for miles per hour. How do I know that? Because the y value, the y value was miles and the x value was time. So 60 miles per hour. Oh, and we just did that. 60 miles per hour. Okay. Now we're going to look at Timars. Okay, Timar did the same thing, but he made his a graph. And so we're going to decide Timar. Okay, so I'm going to go with 1 here at 1 because that's just easier. So how tall is it? So if I look at the distance, that's going to be 50. How far over did he go? He went 1. Okay, how do I know that it's proportional? It goes through 0, 0, and it makes a straight line. It doesn't do any squigglies. So yes, because it goes through the origin and is a straight. And I know all lines are straight, but for this, we're doing that. Okay, so what is its constant of proportionality? Sorry, I always do that. Its constant of proportionality is 50 over 1. which is 50 miles per hour. So who drives faster? Deza. Deza goes 60 miles per hour, and Timar only 50 miles per hour. Now their third friend offers to drive, and the third friend, Alicia, offers to drive Days and Timar home from spring break so that they can share the cost of gas money. When asked how fast she drives, Alicia, she puts it into this. Remember, this is the constant of proportionality. So, does a yes, because it will go through, I misspelled through, the origin, 0, 0, hint, nothing is added or subtracted. Who drives the fastest? Okay, so Deza drives the fastest. Deza goes 60 miles per hour. Timar is 50 miles per hour. And Alicia is 57 miles per hour. Rank from slowest driver to fastest. So, Timar is the slowest, Alicia at 57, and Deza at 60. Now, we're going to compare sculpting class at the university is working on teams of creating modeling clay. So this is their recipe. They can make different types of clay, changing the ratio of flour to water. So we're going to have flour to water. Okay, and these are the recipes. Okay, so if I have flour to water, 2.5 divided by 1. Well, we know that's 2.5. Let's see, 3 over 2. That's the same thing as 1.5. 7.5 divided by 3 would get me 2.5. 4 divided by 2 would get me 2. 12 divided by 8. I can't do that one off the top of my head, but I can say, okay, so 4 goes into that 3 times, 4 goes into that 2. Oh, that comes out to 1.5. I really can't do this one in my head. I'm actually going to use my calculator. And I'm going to do 3.75 divided by 1.5. And I get 2.5. And last but not least, I have 5 over 2, which is also 2.5. So if I look at this, how many different constants of proportionality do I have? I have a 2.5, a 1.5, a 2. So how many recipes did they find? There's 1, 2, and 3 different ones. There are 3 different recipes because there are 3 different constants of proportionality. There we go. Sorry, barely fit it in. Now, the art professor would like all the projects to include the same shade of orange. The students have learned that orange paint is created by mixing red and yellow paints. 3 groups presented suggestions on the shade of orange to be used for their art project. So, the constant of proportionality here is the number, remember y equals kx. The constant of proportionality here is 4/5. How did I know that? It's an equation. You just get it from right here. On this one, we're taking yellow over red. How did I know that? Because X is the amount of red paint, Y is the amount of yellow paint. Okay, so 1.5 over 6 is a little more difficult, but if you plug it into a calculator, I get 0.25. If I do 2 over 8, that simplifies to 1/4. Isn't that the same thing as 0.25? 3 over 12, I simplify that, it gets 1/4, same thing. So these are all, oops, I didn't mean to write that. The constant of proportionality on this one is 1/4. So let's look at the constant of proportionality on this one. So I want to look on this line right here as to where it goes through a lattice point. That right here is a lattice point. This is a lattice point, lattice point, lattice point. So I'm going to look on this line. Where does it go through a lattice point? How about I get rid of my obnoxious, there we go. Where does it go through a lattice point? Let's see. I know for sure it goes through a lattice point here. So how tall is that? That was 6. How far over did I go? I went over 10. So my constant of proportionality is 6 over 10, which simplifies to 3 over 5. Okay. So those are my constants of proportionality. Oh. How do I know that this was a constant of proportionality? Because Avi's group has it in that form. This one right here, how do I know? Because y over x is the same each time. And then Paul's group, it goes through the origin, okay? The greater ratio of yellow to red paint used, the greater the ratio of yellow to red paint used, the lighter the shade of, so the bigger it is, the lighter the shade is. So I want the biggest ratio. Well, these are our 3 ratios. Okay, so I have 4/5, I have 1/4, and I have 3/5. Now, I know which ones they are, but some of you may, well, how can I figure that? Well, on this one, you could simplify it to a decimal. So this would be 0.8. This is 0.25, and this is 0.6. So the highest one is the 4/5. The next one would be 3/5, and the last would be the 1/4. Okay, so write an equation. So remember, y equals kx, where x is the amount of red paint, y is the amount of yellow paint that would create the shade of orange that is between the 2 deepest shades. So the 2 deepest shades are right here. So we want a number that's in between that. So there are all sorts of numbers that we could, oh, nope, I lied. Sorry about that. Deepest would be these two. This is the lightest. So deepest is between here. Okay? So I could do 2/5 K. I could do 1/2 K or 1/2 X. So you just have to find some fraction that is in between those two. Okay, so that's what we're doing for this.